Hello, my dear friends. Welcome to BYJU'S exam prep. Very good evening, all of you. Very good evening. I hope everyone is good, fine, and taking care of yourself. So today we're gonna discuss about a very interesting topic, that is work energy principle, and we'll be taking some examples also. Okay. So good evening, guys. Good evening. I hope everything is good with audio and video. No problem in that. Yes, because last session we had some technical difficulty, so today that is being overcome, right? So good evening, good evening. Let me check from my end also. All good to go. So in today's session, we will be discussing about a very interesting topic, the work energy principle. And like yes, last class also we have talked about kinetics of the rigid particle. So today we'll be talking about the work energy principle, right? So all good, all perfect, no doubt, no difficulty. Anyone having any doubt in the last class session, we can have a discussion, or else we can start with today's session. Okay, and please do share this video to all of your friends. The more the students, the more will be fruitful the session will be, right? Okay, let me check from my end. All good. All good. Okay. Good evening. Good evening. Chaliye. So let's start the session, and I hope so. All good. All perfect. As you know that because gate 2024 के लिए less than an year, because from today onwards, if you plan, like if you want to get a single digit rank, so you have to plan from today onwards. You have to chalk down what should be your schedule for the next let's say 10 months or 9 months, right? So it's very important you try to have a just rough frame out, and definitely will be helping you guys to get to your objective, to get to your goal that you have already set, because till this point of time all of you have now your objective and goals is being set. It's always said that it's never too late, or if you're starting early, definitely you'll be able to gain that benefit by starting early. Okay, good evening, good evening. So my name is Suraj Gopi. I hope everyone knows about me, and you have connected with me on my Telegram channel, that is Mechanical by Suraj, and this is my personal mail ID. You can just do connect with me if you're having doubt or difficulty. If students do have confusion, so you can drop me a mail over here. Okay, fine. And you know that for gate 2024 all we can say up to 90% of scholarship we are giving, and you only have to do is you have to register yourself. 30th April is the day, right? And I hope so everyone has registered themselves. If not yet registered, bhai kar lo yaar, no problem. It will be again a practice session for you guys. You all have set your goals, you all have your objective been set. So one thing is, whenever you are getting chance to practice, and whenever you are getting chance to excel your to show your caliber, just show it, right? So 30th April 12 baje you have to attend and get all the benefits. Hello, no one. Good evening, good evening. Fine. So in the last segment, we have talked about the kinetics of the rigid particle, and we have taken some examples of the D-Lemon principle. If I try to recall, right, whenever I'm talking about kinetics, that means we only have to frame this equation, that is force is equal to, if I talk about the translation motion, or we can say the rectilinear motion, we always try to frame out this equation, force is equal to mass into acceleration. And there are D'Alembert's principle also, work energy principle also, and the impulse momentum principle. So today, in today's session, we'll be talking about this particular very important segment, that is work energy principle, right? Uh, and the best part of engineering mechanics is there are multiple ways to solve the question. You agree with me or not? If you're having a question in front of you, there are multiple ways to solve it. It's up to you which method you are comfortable with, and which method is taking lesser time, so that in lesser number of time you're able to complete larger number of questions, right? That is the only objective. Right? If you're having a whole one day to solve a single question, it's up to you. Just take any one of the method. It is irrelevant. But if you're having a limited time, if you're having only 3 minutes time duration to solve a question, right? So definitely your approach should be perfect. If your approach is not perfect, then you will be taking a lot of time. Might be that time will be useful for some other questions also, right? So it's very important, especially in engineering mechanics, because to solve any question, there are multiple ways, and you have to select that optimal method. So I'll be telling you all the methods, right? Yesterday or the day before yesterday, we have studied about D'Alembert. Today we'll be talking about work energy, and I can surely say whichever method you're comfortable with, just go for that. Okay, fine. So today we'll be talking about the work energy principle, and that in there also we try to frame out the force and the basically what we do, we try to calculate the motion variables. What are motion variables? Velocity, acceleration, displacement, right? These are the motion variables that we need to calculate. Okay, so what is the meaning of this work energy principle? Now, what is work energy theorem? Basically, it states that what we do, whatever work we are doing, okay, or we can say the total work done on the system or the total work done by that force on a particle will always be equal to the change in kinetic energy of that particle. That means I can say the total work done will always be equal to the change in kinetic energy. Okay, the total, I would rather say the total work done will be equal to change in kinetic energy. That means your final kinetic energy minus initial kinetic energy. Okay, fine. Let us try to apply this concept, and let us try to prove it also, right? And then we'll be going for the some examples. Now, let us suppose if I try to understand, now we know that what is work. Okay, we always know what is work. Work is your we can say force into displacement, okay, or F dot S, right? Fine. So in the direction of displacement, if I say there is a body and this is being displaced in this direction, and if I'm applying a force in this, so I can say that this body is being displaced by some displacement S. Okay, so I can say force into this displacement, that will be giving you the concept of work done by that particular force, right? So apart from this, what is the meaning of this word kinetic energy? Because these are the segment which you know individually. Work done you have studied in many subjects, kinetic energy also you have studied, but let us try to combine and let's try to apply this logic. Now, what is kinetic energy? Kinetic energy is the energy possessed by an object due to its motion. Okay, due to the motion of the body, what is the energy being possessed by the body? That we call it as a kinetic energy, or simply we can say that it is that portion of energy which an body possesses due to the movement of the body. Okay, so how we can apply this concept of work and energy separately to a very interesting segment, that is work energy principle. Now, let us suppose if I say there is a body, okay, there is a body which was originally moving with some velocity, let's say u velocity, and after some displacement, it has reached this position, right, and it is moving with a velocity v. It is moving with a velocity v, right? Okay, so over here, can you tell me what will be the work done? Definitely, if you want to change the velocity, you might have applied a force, because we know that force is equal to mass into acceleration. Due to this application of the force, will be having one acceleration will be created. Okay, fine. So can we simply say that due to this change in velocity, there might be some amount of force. Due to this force only, there is some rate of change of velocity coming into existence. Yes, if you're not applying any force, definitely that the body will be moving with the same velocity. That is Newton's first law. When a body is in motion, will be in motion, or the body is at rest, will be at rest, unless and until an external force is applied to it. Okay, so if you want to change the velocity of the body, definitely you need to apply a force. So let us suppose what is the work done. What is the work done on this body? Sir, force into displacement. Force into displacement. The displacement is S. Let us suppose F is the amount of force that is being applied. Okay, or I can say, let us suppose this is having a mass m. So m into a into s will be the total work done by that mass on this for traveling this displacement. Yes. Now, if I want to formulate a relation between the velocities, can we say, because this body will be having a constant acceleration, can we say that v square is equal to u square plus 2 into a into s? So from here I can say a is equal to v square minus u square by 2 into s. Let us place this value in this equation. Can we say work done is equal to m into v square minus u square by 2s into s, right? So cancelling this, will be having half m v square minus half mu square. This is nothing but the final kinetic energy minus the initial kinetic energy. That means I can say that whenever there is a change in kinetic energy of the body, that will always be coming with the existence of a work done. That means whenever a force is applied on a body, due to this force, there will be some displacement, there is some work is being done on the body. So that total work done will be simply equal to the change in kinetic energy. And this is basically your work energy theorem or work energy principle. That means the work done on the net by the net force on a particle is equal to the change in particle's kinetic energy. That means work done is equal to final kinetic energy minus initial kinetic energy. Okay, is this clear? Now we know this particular statement, we have derived this particular theorem. Let us try to apply in some examples. Now let us suppose I'm having an example like this. A body weighing 300 Newton is pushed up at an angle of 30 degrees. So let me draw the diagram for you guys. Let us suppose there is a surface, okay, and there is a body which is being pushed upward with a force of 300 Newton, right? And it's making an angle of 30 degree with the horizontal. It is having a weight of 300 pushed by a force of 400 Newton, right? So this is your 300. Okay, fine. Is this clear? Now, question is, if the initial velocity of the body is 1.5 meter per second, coefficient of friction is 0.2, then what will be the velocity of the body after traveling a distance of or a displacement of 6 meter? Now, can we not solve this question by D'Alembert's or the Newton's second law? That is, the total force acting on the body is equal to mass into acceleration. So from there I can get the value of velocity. But let us suppose I'm applying the work energy theorem to solve the same question, because I told in the starting there are multiple ways to solve a question in initial mechanics. If I talk about motion variables, there are Newton's second law, that is D'Alembert's principle. We are having work energy principle. We are having momentum, impulse momentum principle also, right? So there are multiple ways to solve the question. You can solve this question by using the D'Alembert's also. That is your Newton's second law. But today's session is specifically designed for all the students, those who are comfortable with work energy principle, right? You should be knowing. If you're not able to solve some questions by using D'Alembert's, let us try to have one more methodology so that at least you are able to get the answer, right? So if I try to resolve this force, so we'll be having, let me resolve this. We'll be having 300 cos theta, 300 cos 30, right? This will be 300 sine 30. We'll be having a normal reaction. Now, can you tell me what will be the direction of friction? I want answers from everyone in the comment section. What I need to write, in which direction the acceleration will be happening? Can you tell me? Yes, everyone. What will be the direction of friction between the block and the surface? Yes. Anyone? Yes. Arey bhai, simple question hai guys. The body's tendency, this block is having a tendency to move upward. That is being said, right? Okay. Simple question. If you're not able to solve, I think you are in a very bad situation, right? Simple question. The body is trying to move upward. So definitely the direction of friction will be backward. That is, this will be the direction of friction, F. Okay. So if I try to write the equations, I can simply say F is equal to mu into N. The total vertical force equal to 0. Exactly. Origin. Okay. That means downward. Okay. Fine. At least right. Perfect. We can say the normal reaction is equal to 300 cos 30. I'm not resolving that right now. I'm just not placing the value of cos 30 right now. Or let me take it as 150 root 3 Newton. Okay, 150 root 3 Newton, right? Okay. And we can say, what is the net force acting on the body? Net force acting on the body is, what is the net force acting on the body? That is equal to 400 minus 300 sine 30 minus the frictional force. Now, frictional force is equal to mu into N. Mu into N. Mu is 0.2. Normal reaction is 150 root 3, right? So this will be, I think, 30 root 3. 30 root 3. Hai na? So this will be 400 minus 150 minus 30 root 3. Okay. Yes. So let's calculate and tell me what's the net force acting on the body. Because mechanics mein it's all about 10 minutes of concept. How you are applying that concept is important, right? So 150 plus 30 root 3, 30 root 3, 400 minus of answer 198. 198.04 Newton. Are we getting this? I've just calculated from my calculator. I'm getting the net force acting on the body is 198.04 Newton, right? So this force is responsible for that change in velocity. Initial velocity is 1.5, right? So now we can apply the work energy theorem. The work energy principle or work energy theorem, right? That means the total work done will be equal to change in kinetic energy. Okay, fine. That is half into m into v square minus u square. Now initial velocity they have given, you have to calculate the final velocity. Now what is work done? That is net force acting into displacement. Now they have given the displacement as 6 meter, right? So it will be having 198.04 into 6 is equal to half into mass is given how much, 300 Newton weight hai. So 300 divided by g, this v square we need to calculate minus u square is 1.5 square. Okay, solve it and tell me what is the value of. Okay, so by this way I'm applying the work energy principle to calculate the velocity of this block. So that will be somewhere around, let me calculate, by 300 into 9.81 plus 1.5 square and the root of this 8.94 meter per second. Okay, 8.94 meter per second. That means the velocity of this block after moving a displacement of 6 meter will be having a velocity of 9.82 meter per second. Is this clear? You can solve the same question by using what? By using a concept of D'Alembert. What we can do, net force is equal to mass into acceleration. There we can calculate the value of acceleration. Once I'm getting the value of acceleration, I can use v square is equal to u square plus 2 into a into s. That's it. You can go with that also. But the thing is, the method, you should be knowing what are the multiple ways to solve a question and which method you are comfortable with, you have to opt that. Is this clear? Understood? That is the beauty of engineering mechanics. It's all about concept, guys. It's not a question. It's not a subject that you'll be having one formula. Remember that formula, apply that formula, getting the answer. No. You have to know the logic. You have to know the concept. Then only you'll be able to solve the question in lesser time. Okay. Chalo, let's take one more problem. Chalo. And this question you guys need to answer and you have to tell me the answer for this. In a police investigation of tire marks, it was concluded that a car while in motion along a straight level road skidded for a total of 60 meters after the brakes were applied. If the coefficient of friction between the tires and the pavement is 0.5, what was the probable speed of the car just before the brakes were applied? Can you tell me the answer? Yes. Can you tell me the answer? Chalo, let's see. No one, Giri. Tell me the answer in the comment section. Let us suppose I'm assuming this as the body, right? This is the body, and apply the work energy theorem. Okay, because today we are talking about the work energy principle. So let us try to discuss this method only, right? You can apply any method, but because we are talking about work energy principle only, so let's go for this. So there is a body and it was moving with some initial velocity, right? It was coming to rest after moving a displacement of 60 meter. Okay, your final velocity equal to 0. The coefficient of friction, that is 0.5. You have to tell me what was the velocity of or the probable speed of the car when the brakes were applied. Chalo, bataiye. Tell me in kilometer per hour. Okay, normally we are having the speed in kilometer per hour only. Okay, quickly apply the work energy principle to get the correct answer, right? Chaliye, quick. Now, what's the total force? If I try to draw the FBD, because FBD is the best way to analyze any question. So if I try to draw the FBD, we are having the weight of the body, right? We are having the normal reaction. We are having the frictional force. That's it. That's it. Or can we say the net force acting is nothing but minus frictional force, because the body is trying to move in this. This is the direction of motion. This is the direction of motion. So I can say what is this is minus mu into n, that is minus mu into w, that is mg. Okay, fine. So this is your net force. So now applying the work energy principle. Now applying the work energy principle, we can say the total work done will be equal to change in kinetic energy, right? Okay, what's the total work done? Now in this case, we are getting a negative work done. The reason being the friction is applied opposite to the direction of motion, right? So we are having the net force acting into displacement is equal to change in the final kinetic energy minus the initial kinetic energy, right? So this is minus mu mg into s. Now final kinetic energy will be 0, because here the kinetic energy will be equal to 0 because the velocity is 0. We will be having the initial kinetic energy in terms of u. So this is 0 minus half into m into u square. So we are having mu mg into s is equal to this minus and minus cancelled out, half m u square, right? So we are getting the value of velocity is equal to 2 mu g s root of that. Okay, so 2 into what's the value of mu? Mu is 0.5. This is 9.81 into s is how much? 60 under root of this. Okay, fine. Let's try this. 9.81 into 60 root of this. So it will be 24.261 meter per second, right? Okay, or I can say this will be equal to how much? 87.34 kilometer per hour. Hello, good evening. Right? Okay, fine. So very easy question. Now, if I try to solve the same question by D'Alembert, what we'll be doing? You'll be calculating the value of retardation. You'll be calculating the value of retardation. Once you calculate the value of retardation, right? Fine. You can apply simply v square is equal to u square. V square is equal to u square plus 2 into a into s. Good evening. Right? Okay. Very cut short, straightforward. I hope so. You have understood a very interesting concept of work energy principle, and that is the beauty. When we are knowing the concept, when we are trying to apply that concept in the different questions, we get more clarity. Okay, fine. So we have studied D'Alembert's, we have talked about the work energy. One task I am giving you, try to study impulse momentum. That is also very easy, right? What is impulse momentum equation? The impulse is nothing but the change in linear momentum, right? F into t is equal to change in momentum, that is mv final minus initial velocity. That's it. Okay, the impulse is nothing but change in momentum, linear momentum. We can apply that concept also, right? So it's up to you which concept you are applying, because on Saturday, today is Thursday, right? So on Saturday, same timing, 10 p.m, we'll be having the practice session. These were only very basic question. This is not a level of question that we need to have. Only for understanding the concept, I've taken this example. In practice session, we will be taking some good level of questions, and I want you guys to quickly recap whatever we have discussed. The D'Alembert's we have discussed, the work energy principle today we have talked, right? Try to revise the friction also, because friction is also being taken. I've taken a session on friction, static friction, the condition of tipping also, right? And soon we'll be having one video on wedge friction also. So you will be having that video in front of you. So all these concepts that we have studied, we will be practicing. And mark my words, it's not a very basic level. We will be talking about the advanced level of question. Mediocre, we'll be starting from mediocre, then we'll be going to advanced level. Okay, because I want you guys to have some brainstorming on Saturday 10 p.m. Okay, so we'll be meeting now after this on Saturday, right? On Saturday at 10 p.m. we will be meeting and we'll be having that brainstorming practice session. Okay, is this clear? So whatever doubts you are having, please do let me know right now. We can have a discussion, right? And if you still have you don't have any doubt right now, but if you have the doubt afterwards, you can contact with me also on my Telegram channel or on my mail. I've already shared that also, right? Okay, so this startup series was started from 18th of April, right? 18th April से we have already started, and because starting में we'll be talking about only concept and one session for numerical. Okay, so on Saturday we'll be having that practice session at 10 p.m. Stay connected so that we are not having any doubt or difficulty. So this is my Telegram channel where you can connect with me and we can have a discussion, right? So these are our aspirants, those who have shined again, we can say in GATE 2023, and in 24 I want you guys, your photographs to be pasted, right, next year, so that your juniors will be seeing your hard work and your dedication, because it's all about hard work and dedication. Okay, competitive examination is not about how much you are able to complete the syllabus. It's basically how much you are able to apply the concept in the examination hall. Okay, in GATE examination specifically, it's not about the examination of formulas, it's examination of applying the logic, applying the concept, and how quickly you are applying, that is important. Okay, so thank you guys for joining with me. I hope you all enjoyed. So we'll be meeting soon in the next session. Till then, stay connected with our very beautiful platform, that is BYJU'S Exam Prep. And if you're having any doubt or difficulty, please write in the comment section. Okay, thank you guys. Bye bye. Take care. Stay safe. Enjoy your day with BYJU'S Exam Prep. Thank you.